So the first word problem is find the largest number which divides 615 and 963, leaving remainder 6 in each case. That means the number which we have to find, the largest number, suppose let x be the required number which you are asked to find. That is the largest number which divides both and leaving 6 remainder as remainder in each case. That means what? That meaning is that means 615, when it is divided by x, it will have some quotient and the remainder will be 6. And the other number 963, you see 963, when we divide by this number, it will have some quotient, say q dash, some different quotient, and the remainder will be 6. So this is the situation, that is to find the largest number which divides both, leaving 6 in each case. So that means if x is this largest number, so this will, when I divide this, remainder is 6, and when I divide this by x, remainder is 6. You understood the thing? Something like that. 615, when dividing by the largest number, q is the quotient and remainder is 6. And again, when I divide the other number, 963, q dash is the quotient and remainder is 6. So that is the question. That you understood the question. So the question, we have to find the value of x. So you see one thing, from this, what is xq? Xq is 615 minus 6. How much it is? 615 minus 609. 609. And from this, what is xq dashed? X into q dashed is 963 minus 6. With 10 transpose to the other side. And how much it is? 963 minus 6 is your 957. So this we understood. So that means these two numbers are multiples of x in each case. So this x, what this is, x is the largest number which divides these two. So therefore, what is x is nothing but the largest number, that is the largest factor, the highest common factor of these two numbers, 609, 957. This is the main thing you have to understand. Is it okay? So, how we are getting these two numbers? By subtracting the remainders from the numbers. Remainder of the numbers. So, these two are factors of x. Largest factor, highest common factor of these two numbers is your x. So, by the Euclid's division algorithm, we can find out this. You know the method how to find it. I have shown in the previous class. So, that will be the answer. And you will find it out that the answer should be, I am giving you the answer. And you know how to do it. You will divide 957 by 609. In this way we will proceed. Okay. And generally you see, when the numbers are big, very big size, then we follow Euclid's division algorithm. And if the numbers are not that big, small 2-digit numbers, we can go for fundamental theorem of arithmetic. That is, by prime factorization we can find out the HCF and LCM. But when the numbers are very big, we always go for Euclid's division algorithm. So in this way we will be doing the find out the HCF, and the answer should be 87. Okay, that should be, you will do yourself and you get the answer to be 87 in the process. Okay, so you will do this. This is again your homework to find out the HCF of these two, and that should be 87. So this is first word problem. Okay. The next problem, similar but a little change. So the question is here. Okay. The next question. Find the greatest number, 1 to 85 and 1 to 49. 285, similar number. Change. 285 and 1 to 49. 285 and 1 to 49. Find the largest number, divide this and this, leaving remainder 9 and 7. Leaving remainders, instead of same remainder, you 9 and 7 respectively. 9 and 7 respectively. Okay. In the previous question, they were leaving the same remainder, but here they are leaving different remainder. So the same thing, let x be the required number, that is the largest number. Then when I divide this number 285, let q be the quotient, and what will be the remainder? Remainder will be 9. So here it will be 9. And when I divide the other number 1 to 49 by x, q dash is the quotient, different quotient, and the remainder is 7 here. So this is the situation, different remainder. So I can write the first number 285 is equal to x into q plus 9, and the other number 1249 x into q dash plus 7. Okay. Replace division lemma, and so x q is equal to 285 minus 9. 285 minus 9, and x q dash is 1249 minus 7. 1249 minus 7. 1242 and it is 276. So what will be x? It will be HCF of these two. By the same logic, 276 and 1242. Is the thing clear? How I am getting the thing? So again, by Euclid's division algorithm, you can find out the HCF of these two, and that answer is, let me give you the answer. The answer will be 138. 138. So again, it is homework. You find out the HCF of these two numbers by Euclid's division algorithm, and the answer should be 138. So the largest number which divides these and these, leaving remainders 9 and 7 respectively, will be the number 138. Okay? Okay. So I think the thing clear. Let me see any other one now. Okay. Now let's come to the word problem given in the NCERT book. In the NCERT, I have some word problem, that is first word problem. An army contingent of 616 members. Okay, so this is fine. Now let me give you the NCERT one, a solution of the NCERT one. Exercise 1.1, exercise 1.1 NCERT. Question number 3. Question number 3. It states that an army contingent of members 616 members. Army contingent. Okay, is to be marched behind an army band of 32 members. 32 members, army band. So 32 persons are there, and 616 army people will follow these 32 members in the band. Okay. Now you have to okay, and so given the two groups are to merge in the same number of columns. That is same number of columns, you know, that means same number. If the bands are 4 columns, then army will be also follow the 4 number. That means this is the way. In this way they will follow. Okay. If suppose army band are in this way going, then the army contingent will go in this way, etc. That is the scenario. Okay, that is same number. These are the columns. Here I have shown you 4. That is, I don't know how many columns will be there, that you have to find out. So number of columns in which the army bands are marching will be same. The number of columns in which the army contingent will be marching, that is given. So you have to find the maximum number of columns in which they can march. To find maximum number of such columns, such columns you have to find out. So you see here, you have to understand that is this number of columns has to be a factor of 32, because the 32 army people have to be distributed in this column. So let me write, let n be the maximum number of columns. What we have to find out, we write it as a variable n. So let n be the maximum number of columns in which they can march in this way. That means there are n columns. N columns, 1, 2, 3, etc. N columns are there. So you see, this n, number n, has to be a factor of this 32. Is not it? Because you see, these 32 members have to be accommodated in this space. So there are a number of columns who has to be a factor of 32, and also the number of this column n has to be factor of this 600, because there are here are 32 members and here there are 616 members. So this n has to be factor of both these two, this and this. And since maximum number of columns is required, therefore n will be the highest common factor of 32 and 616. That's why. That is the reason why there has to be the HCF, because these number of columns which are asked to find is factor of these two, has to be common factor, because the number of columns in which they will be marching has to be same. So the number of columns has to be the common factor of both these numbers. And since maximum number of columns is required, so I'll be taking the highest common factor. NCERT highest common. Yes, highest common factor I have to take to get the maximum. So again, by Euclid's division algorithm, you'll be able to find out this. Okay, so that's all for today. In the next class, I'll be explaining more problems, and by that time you can do from your side books or whatever material you have. But okay, that's all for today.